So there's just a couple of tricks here. Number 5, anything, no matter, whoa, where did it go? No matter what that base is, if it is a positive base and then the answer is negative, the result of a positive raised to a power can never result in a negative. So what's there can never be negative and it can never be 0. So if either of those things happen, it's no solution. And on the homework, it says to you, it's the word impossible. So if it was a negative number there, or if it was, because the base is never going to be negative, but if the base is positive, you can't raise it to a power to make it to be negative, or it can't be 0 in that either. That. For 9, you get to something where it's expanded and it asks you to evaluate. So in this case, like while I can reduce the second one, log base 4 of 2 would be a half because you could square root the 4 to get the 2. There's nothing you can do with that 4 and the 32. But if I condense first, because there's 2 logs, if I condense first, so anytime we're trying to simplify and it's expanded, you want to condense. If I condense and it's subtraction, it becomes division, and then I'd get log base 4 of 16, and then 4 to what power gives you 16? 2. So you can go all the way with that one. So if you're evaluating or simplifying, and it is expanded, try to condense it first and see what you get, because that could have happened with a multiplication or it could have happened with a division. But it will usually get to the point in which you can simplify a little bit further. For 10, okay, when I look at this, there's nothing I can raise 16 to get to 64, whole number wise. But if I can break 64 down into a product of powers of 16, then I can keep going. So like 64 is 16 and 4. So then I can say log of 16 would be 16 times 4, or of 16 times 4, which replaces the 64. And then because it's multiplication, when I expand it, it becomes what? Addition. Good. So this would be log 16 of 16 plus log 16 of 4. Log 16 of 16 is what? 1. And log 16 of 4 is? How do I get from 16 to 4? Look at it in reverse. Is there something I could raise 4 to get to 16? Squared. So reverse it, right? And it's 1/2. It's the square root of 16. So that's 1/2. And then my answer is 1.5 or 3 over 2 or 1.5. Like any of those would have worked. So if this is the square root of that, then it would be the same thing as having an exponent of 1/2. So if you have to square root the base to get the big number, that's the same as having an exponent of 1/2. So if it was log base 25 of 5, it's also 1/2. If you have to square root the base to get to the big number, then the power would be 1/2. Good? Yeah. Yeah, that's the one I have on the next slide. Oh, no, yeah. Okay. So then the other one is 16. Okay. When you expand this out, it starts as division. So if I expand it out, I get log base 3 square root x squared minus 9 minus log base 3 of 9. And then the exponent on that square root becomes 1/2. So this would be log base 3 of x squared minus 9 to the 1/2 minus log base 3 of 9, which I'll go back and simplify in a minute. That 1/2 bumps to the front. So it's 1/2 log base 3 of x squared minus 9 minus log base 3 of 9. And then if that x squared minus 9 was just like a single term, I would leave it alone. Like if it was x minus 9, I'd be done. But because that can actually be factored, you can go a step further on that one. That is x plus 3 and x minus 3. And then you're finding the log of a product, which means it can be expanded into an addition or a sum. I don't know if you'd see something that tricky on a test, but just know it's possible. And then that last one, some of the versions of the questions would, like, it was like log base 3 of 5, and that you can't do anything with. But some of the versions of the questions, there's something there that can be simplified. So can I raise 3 to a power to get to 9? It would be what? Good. So I do 1/2 log base 3 of x plus 3 plus 1/2 log of 3x minus 3 minus 2. So again, probably not a test question, but an application of stuff we've done before, like it's bringing back in the factoring, and the factoring is definitely going to come back in the next section when we get to solving log equations. There's a lot of stuff like that. So any other questions that popped up while you were working? Okay, you can keep working. This one said graph, right? And then we were finding all the parts of it, right? So this would be a vertical asymptote, domain, range, x-intercept. Because there's parentheses with the equals there, this means I'm going to have a vertical asymptote. This is actually a shift to the left, 5, but because the order is weird there, you can just set it equal, I'm going to shift to the right, sorry. You can just set it equal to 0 and add the x, and you get x equals 5, and that's your vertical asymptote. So I know just starting out that my vertical asymptote is at 5, which means it's going to be shifted. So your quiz is going to have graphs on it without your graphing utility. Like your quiz, you won't use your graphing calculator at all. They would not be LNs, but they could be any other kind of log. So this would be F5. And it's going to ask you to, the graph is actually multiple choice, but it's going to ask you to identify all those other parts. So you'll add that in. So that's the first thing, vertical asymptote there. Second thing is I'm going to get this into exponential form. So y would equal log base e of 5 minus x. The e picks up the y. So e to the y equals 5 minus x. Subtract the 5. E to the y minus 5 equals negative x. And then that negative changes all the signs. So negative e to the y plus 5 equals x. And then when you plug in, you're plugging in for the y. So negative e to the first plus 5. Negative e to the 0 plus 5. And negative e to the first. Oh, sorry, this is negative 1, sorry, plus 5. So what's weird about it, and sometimes I would say maybe it's even easier to switch this and make it 5 minus e to the y, is that negative is not part of the base. So like when I raise e to the negative 1, I have to keep it as e to the negative 1 and then put the negative on. So I don't have my calculator in front of me. Do you know what e to the negative 1 is? I can't remember. Is it 0.6? To the negative 1 is 0.36. We're going to round it to the nearest tenth, right? So 0.4, but it's negative. So negative 0.4. Cancel. I don't know what just happened. All right, so this is negative 0.4 plus 5, or 4.6. Negative e to the 0 is 1 plus 5, so that's 4. And then negative e to the first would be negative 2.7 plus 5, or 2.3. And then you go to your graph. 4.6 and negative 1, 4, 0, and 2.31. Because of the negative on the x, it's going to flip it horizontally. So instead of pointing to the right, it's going to point to the left, which is why that curve goes in that direction. Go ahead.
I always mix up like where the points go on like
The x and the y.
The x and the y chart. So what is like a good way to remember?
Maybe after you put them in, rewrite them in coordinate point form.
So, because it's always x. Like that's where the points go. It always goes on.
Yeah, but it's opposite for exponential. And I've seen it happen, like at least a couple people do it every year. They get all the points right, and then they go to graph it and they swap them. So maybe write out, like take your t-chart and rewrite your coordinate points and then graph from your coordinate points instead of your brain being switched.
And it's only y when it is an exponential. When it's
Correct. Yep. So one of the graphing questions on your quiz is going to be exponential and one of them is going to be log.
okay.
So then this, my domain goes from left to right here, right? It's normally from the vertical asymptote to the right, but this time it's reversed, so it's negative infinity up to the vertical asymptote, which is at 5, parentheses on both. The range is negative infinity to positive infinity, the same for all logs. And then the x-intercept is the one from the middle of your t-chart or from your graph, which is 4, 0. It's going to ask you for all those parts.
Thank you.
You're welcome.